Hello and welcome to the next chapter of KNX Advanced course. It calls Interworking. My name is Amir and I hope you enjoy it. The KNX Association not only took care of the standardization of the protocol, means KNX protocol, also this association laid down rules for the encoding of useful data inside of the telegrams. So the useful data can be understandable for every product in KNX. Okay, it doesn't matter who manufactures. So in this chapter we are going to talk more about it. So notice that without a standardization, devices of different manufacturers would be able to talk KNX but could still code the useful data contained in the tail of the telegram differently. Example, manufacturer A would code temperature as 1 byte and another as 3 bytes. For a start, such group objects could then not be linked by means of ETS, and secondly, these devices would not understand one another. Okay, so what we do in KNX to get rid of these problems? In order to ensure interworking between manufacturers and even products of different application domains, KNX Association therefore laid down formats for common functions like switching, dimming, blinds control, integer, float value, percentage, date and time, HVAC mode, scene control, and many others. These formats referred to as a KNX standardized data point types. The most common data types were also standardized on a European level and integrated into EN 590 series as a Part 3.3. If a standardized format for a certain function exists for certification, the KNX manufacturer is obliged to use this format. Compliance to the format is also checked during the KNX interworking test as it carried out by KNX accredited test labs. So, in KNX Association, we have some labs around the world and mostly in Europe. So the manufacturers, before they can release their product officially with KNX logo, they should send those devices to the labs for test. Yeah. So the labs should make sure that everything is fine. And the standardized data points are provided by the devices for fully interworking. So because of this, we can say the KNX is open protocol because the products are checked as interworking. Here you can see the KNX lab around the world. Yeah, and for example, if we go to the Germany, we can see which labs are in Germany are ready to test the product from the different manufacturers to let them release the product with KNX logo around the world. Great. So let's continue. So what are the advantages of interworking? The benefits of home and building control only become truly visible when devices of different manufacturers and different application domains interwork. Okay, because if we can use different devices from different manufacturers, so we can provide the optimum solution for the customer. The lowest cost, the highest performance, and so on. For example, presence detector is part of the alarm system at night. Room thermostat of manufacturer A set position of valves of manufacturer B, so they can interwork to each other. All of button of manufacturer A switches the light off, controlled by switching actuator of manufacturer B, C, D. For example, we have the switch actuator from manufacturer B, dimmer actuator from manufacturer C, and so on. Timetable of manufacturer A ensures presence simulation, thereby controlling blinds of manufacturer B. It goes without saying that this is an enormous benefit to end user. When a product line A is defective but manufacturer A has discontinued product line, the end user can find a replacement of manufacturer B. Okay, so the end user never depends on only one manufacturer. We have more than 400 manufacturers in KNX, so we can use another manufacturer product. A system with true interworking also attracts a manufacturer of niche products, as one single manufacturer can simply not offer all possible solution, from lighting to HVAC to load management. It is very true. Nobody can manufacture everything. Okay, some company are special in sensors, some company are special in electrical cabinet devices like actuators, some company are so powerful in software and so on. So with KNX interworking we can put all of them together. Okay, great. And if I want tell you some example, for example, for software we can refer to NetX automation. For sensor we can refer to Elsner, Steinel, and for actuators we can refer to ABB, Schneider Electric, Siemens, and for keypad also we can refer to ABB, Schneider Electric, Zenio, and yeah, so you can see with different products we can provide the best solution for the customer. Okay, principle of KNX interworking. We want to talk more about functional block. For KNX devices that are programmed with ETS, KNX requires that at least the group objects are coded according to KNX standardized data type. We can see the data type in ETS. Let's see it. For example, here in this power supply from ABB, we can click on group objects, bus voltage, and we can see the data type is electrical potential. We come here, this is a data point type is 14027, and if we go by mouse on it, it's provide the details. Okay, so for each data point we have the description under the setting properties setting. Yes. Okay, for some of devices type like dimming, blind control or switching with priority, it is however necessary that actuators show a certain behavior when data is sent to the available group objects, not one. In this case, the specification of functional block becomes necessary and needs to be compiled with during KNX production certification. So what it means for some function like dimming control, not only one group objects are enough, we need at least two group objects, switch on off and relative dimming. Or for blind we need at least two group objects, move and stop. So the combination of group objects provide us the functional block. Functional block group a number of input, output and parameters. For this combination and precise function description is provided. It means the functional block in KNX also is standardized. Okay, so the lab take care of it, and they make sure that the standard applications are provided by the devices who manufacturers promise to make it. Okay, and that is fantastic. Coding of data point type. A group object is regarded as a certain type of data point. Also, parameter can be regarded as a data point. The data point type is determined by the following four elements. First of all, format. What is format? Format, which fields is the data point type composed of. Each field can consist of one or several bits. Okay, so remember that if we want, for example, to use the relative dimming, so every manufacturer provide the 4 bits useful data. Okay, so the format is provided. Coding, how is the data coded? Okay, so the coding is important and it's standardized. Value range, are there any limitation to the value range? There may be different minimum and maximum values or valid value for each field or list of valid values. So the minimum and maximum are standardized for data type. Unit, which unit does the data of individual fields have? Okay, is it the temperature in centigrade, Kelvin, Fahrenheit, and so on? So everything is standardized in KNX. Remember that. So if you come to this schematic, you can see the data point type, the format, coding, value range, and unit are standardized in data point type. Okay, it's not only a size, it's more than a size. So in next slide we talk about principal data point type classes. 5 classes can be distinguished according to their internal structure. More explanation is given in the next clauses. So simple types, this is one of the data point type classes. What is a simple type? Examples of simple types are Boolean values, 0 or 1, pure numerical values. Okay, so this is a simple type. Enumerated types, the next one. Enumerations are used for data points with a clearly limited number of values and no precise hierarchical order. Okay. If a data point uses an enumerated data type, all possible states shall be described. If invalid, undefined values are sent. No malfunction may occur. Example is a toggle between comfort, standby, and night. Okay, this is a special mode in HVAC for room thermostat. So they are in an enumerated type, and even when you want to choose it in HVAC thermostat, the data type called enumeration. Okay, there's some number between 0 to 255. Okay, so when we choose the special mode, we can see the data point type. For example, the 1 is for comfort, 2 is for standby, 3 is for night, and 4 is for building protection. Okay. Great. Structure type. Structure data point type consists of several parts which are combined in a data point. Only fields which cannot be interpreted meaningfully on their own can be combined to a structured data point type. Examples are KNX relative dimming. Okay, so this KNX relative dimming, it's a 4-bit data type. Okay, so one bit, one of the bits is 0 or 1, so it provide us the detail, is it increasing or decreasing, and the 2 of them is provided for us is the resolution of the relative dimming. Okay, the multi-state type, multi-state data point types are intended for transmitting data. So they have 2 characteristics. First of all, it says it's a hierarchical sequences, and the next one is encoded values are meaningful. Example, a fan controller, the manual fan controller can drive the fan from standstill over 5 position up to maximum. Okay, so when you use the manual fan, it's the first one is slow, the next one is medium, and the third one is high. Okay, if it's 3-step fan. So this is a multi-state type of data point. So the book provides us some nice conversion to understand much better what we talk about it. So here, to be able to cover all cases in which sender and receiver, for example, in one group address we have the sender from sensor and receiver from actuators, operate with many different steps. They both convert their steps to a range between 0 to 255. The following applies for the sender. The value is equal to required steps on number of steps multiply 255. This value is rounded up or down and sent as a byte without a sign. The following applies for the receiver. Step is received value, multiply number of steps divided by 255. For example, a sender with 3 steps, okay? For example, we have the keypad with 3 steps. Control a receiver with 5 steps, okay? Like the actuators with 5 steps. So if we press step 2, what's happening? The step 2 of sender is thus transmitted to, according to here, the required steps is 2, the number of steps is 3, 2 from 3, multiply 255 is 170. The receiver interpreted this as a received value 170, multiply number of steps, okay, it's maximum 5, and 255 is equal to 3, and moves to its level 3. So if we press the second steps in receiver, it's go to the third steps. Great. All data point type have a unique identification consisting of 2 digits. The first digit we can see is for example, the scaling data point type is 5.001. The first digit denotes the format and the encoding. The second digit represents the value range and the unit. Okay. In the course of technical development, KNX members may submit suggestions for a new data point type to a KNX association. New data point type are also drawn up by the responsible KNX working group, the WGI working group Interworking, when elaborating new application data point descriptions and corresponding KNX standardized functional block. Group objects complying to DPT type with a size of 6 bits or less only use the bits directly following the APCI. Any unused bits are set to 0 in the KNX telegram. Any group objects complying to DPTs with the size greater than 6 bit will result in a telegrams where the 6 bits following the APCI are set to 0 and useful data padded after these unused bits. Okay, so every if I want to tell you here, you can see every data point types consists of 2 parts, the first part and second part. Okay, we can see here the first digit denotes the format. Okay, so here and the second one format encoding, and the second one represents the value range and units. Okay, yeah. For example, about the temperature, 2 bytes, you can see the 9 is, of course, is temperature, but the second part it's provide us, is it the Kelvin or centigrade and so on. You can see all different things here. Okay, in this chapter from Advanced Book, you can see the most important standardized data types. For example, I put the Boolean in this slide. You can see the Boolean data, DPT 1 point blah blah blah, is used for all possible applications in which 2 different values are to be set or sent. Okay, you can see the Boolean data. One is for format, but the third part, the second part, it's defined that it is alarm, false, true, disable, enable, alarm, not alarm, low, high, decrease, increase, and so on. So for the important data types, it's 4 bit, 1 byte, 2 byte, 4 byte, and so on. You can refer to the KNX Advanced Interworking chapter and see the details. Combination of DPTs into devices. For 2 very common device types, the combination of DPTs into devices has been standardized and obligatory for certification. These are standardized called functional block. As I said, we should put different group objects together to make some specific operation like dimming or sign blind actuator. Functional block for dimming actuator, we get through it. to study more. A dimming actuator shall per channel at least support these group objects as complying the underneath stated DPT. Switch, okay, relative dimming and absolute dimming. So this is for dimming. So this is the minimum setting. Of course, in basic course, it is only switch and relative, but here in advanced course, it's recommended. This is a minimum functional block that is tested in lab by the KNX laboratory. So these standardized data point type should be provided by the manufacturers to get the certification. Apart from these, any other objects are optional. For example, in some dimming, we can change the speed of the dim. Okay, we can see the status of the dimmer actuator. We can have many group objects. So all of them are optional. Dimming actuator basic status diagram. The basic function of the dimming actuator is described in the following status diagram here. A dimming actuator can find itself in one of these states depending on which telegram it receives. So, either the dimmer actuator is off, dimmer actuator is switched off, or on, dimmer actuator is switched on, at least the lowest possible brightness is set. Okay? You remember that in phase dimmer we have the relay actuator inside the actuator. So when it's on, the relay is closed. So the 230 volt is going to the ballast inside of the dimmer actuator. So the dimming controls is enable brightness adjusted in direction of the set point. You remember we have the digital analog converter in dimmer actuator. The change from one state to another is triggered so-called events. Event includes off command, switching object receive 0, on command, switching object receive 1, dimming up, dimming object receive a new value, upward dimming direction. In relative dimming, you remember one of the bits from 4 bits provide us the details that it should be up or down, and the next one is down. Stop, dimming object receives value stops, okay? When you release your hand from the keypad in a standardized dimming, you stop dimming. Dimming value off, when you do the short operation on the keypad, you switch off, dimming objects receive value 0, dimming value in percentage. For absolute dimming, we have the absolute dimming. You can send the percentage to the dimmer actuator, but keeping in mind for the new actuators, if you go back for the dimming actuators in long time ago, they don't have, I never see the percentage, but nowadays every dimmer actuator have this. And also when we talk about the dimming actuator, also we cover all related things. For example, if you have the actuator for dimming 1 to 10 volts DC, and also for dolly you have the same group objects, okay, like the dimmer, because also those are lighting control. And value reached, brightness has reached the set point. The event value reached is an internal event. The function of the application software of a dimming actuator is illustrated by the following status diagram. The ellipses represent the state, while the arrows represent the event. So it's something like this. This is a behavior of check during KNX certification. Okay. You can see we have the on, off, and dimming. In on we can send the on, off we can send the off. In dimming, specific value. Okay. And with the specific value, we can dim up or dim down by the relative with percentage absolute. Okay. Short operation make it off. Short operation make it on, and similar concepts. So everything, so this behavior should be checked in KNX certification test according to the KNX detail from this chapter. Thank you very much for your time. I hope you enjoyed and learn much more about KNX, the certification, interworking, and so on. Please go through the chapter of interworking from the KNX Advanced course. You can see much more about this material, and I hope you enjoyed. Please let me know if you have any questions. Have a nice day. Thank you. Bye.